In this video, we're going to be covering derivative graphs and relating f, f prime, f double prime, and what does one tell you about the other. It is kind of going to be repetitive because originally these boxes and this backside were separate in our review time, but because of everything that's happening, I decided to put it together. So just know if it seems repetitive, it probably is. So the first thing this box talks about is how do you find max and mins. Now really this sign chart is only for relative. So I went ahead and already talked about absolute max and min up here. I said if it's absolute min or max, you must check the endpoints, but you shouldn't have probably really need a sign chart if you're doing absolute. So I'm going to label this let me go ahead and do green since we put that in the box. Relative max and mins, or local. Sometimes they use the word local. So how do you find the relative max or min? Is you take your derivative and set it equal to 0, and undefined, what is that? To get your critical numbers, but you only have undefined if it's a fraction, right? So normally it's just equal to 0, but if you have a fraction, then you just, to be undefined, you set denominator equal to 0 and the numerator equal to 0 for it to know when it equals 0. You just separate the top and bottom if your derivative is a fraction. And then you create a sign chart and you put your critical numbers on your line, you pick numbers in between, and you plug it into the derivative, right? For a sign chart, you always plug in your test numbers into whatever you got your numbers on your number line from. And then you put positive or negative, and then if it switches from negative, because that would mean the derivative's negative, so the slope is negative, to positive, that would give you a minimum, and if it switches from positive to negative, that would give you a maximum, and if it doesn't change, then it's neither. It is still a critical number, but it's not a max or min. And then if it wanted that would give you the x value of your max or min. If you wanted the actual max or min value, that would be a y value of the max and min. You'd have to plug it back into the original to know that. And again, if you're doing absolute, you need to think about your endpoints too. So then how does that relate to point of inflection? To me, these processes are similar, but max and min comes from when f prime equals 0. Point of inflections come from when f double prime is 0. So what is the definition of a point of inflection? It's when you switch concavity. When the original graph switches concavity. So how do we know concavity is based on f double prime? So you do the same process, create a sign chart. They're technically not point of inflections. They don't have a name if it doesn't switch. So that's why it says possible point of inflections. And then you pick your numbers and you plug them into the second derivative because that's what you use to get the numbers on your number line, right? That should stay the same, what you use here and what you plug them back into. And you do positive or negative, and it's a point of inflection if it switches signs. Okay, so that is how you use sign. That's when you use sign charts. Now, if you're just talking about when your function's increasing or decreasing, we should know this by now. It's increasing if the derivative is greater than 0, increasing if f prime of x is positive, and it's decreasing if f prime of x is negative. That's what less than 0. And if your derivative is equal to 0, then it would be constant. Right? Because that's the slope. So that should make sense. Because the slope is positive, so your function's increasing. Your slope is negative, so your function's decreasing. Now concavity is, you can think of it like the slope of the slope. Is it slowing down over time? If your slope is slowing down over time, then it would be concave down. If your slope is speeding up over time, it would be concave up, right? So that's why we use f double prime. So if your f double prime is greater than 0, which would be positive, then your function is concave up. If your f double prime is negative, then your function is going to be concave down, right? So that concave up would be like anything that looks like a U. It could be decreasing or increasing, so it could just be half of that U. But if you looks like a cup, and then concave down is like a frown. So the slope over time is slowing down, or the slope over time is speeding up. And then something else that the concavity tells you is if the tangent line is going to be above or below. So if you think about, in this case, f double prime is greater than 0, so that tells us it's positive, so it's concave up. So if you draw concave up, it looks like this. So if you draw a tangent line anywhere on concave up, any point you pick, and you draw a tangent line, you should be drawing your tangent line underneath your curve. Which means if you're going to use your tangent line to approximate a value, it would be under the curve. It's going to be an under approximation. So your tangent line would be an under approximation if your function's concave up. So if it ever asks about that, it's based on the concavity. And so then if your function is concave down, because f double prime is less than 0, negative, if you draw concave down, anywhere you pick a point on concave down, when you draw your tangent line, you should see that it's above the graph. So that's a bad tangent line. But those tangent lines on a concave down function would always be an over approximation. Okay. So if they happen to ask you about that, not super popular, but they could bring that up. So on the back, again, it's just kind of summarizing, but this is trying to, because normally what they give you is a f prime graph or a table, but chances are it'll probably be a graph. So how do we use f prime to determine things about f? That is an important topic. So all these statements are about f of x. I should have wrote in front of all of these. F of x has a relative max and min, or I guess f of x relative max and mins occur at critical points. So when f prime is 0 or undefined. So how do you find f of x relative max and mins looking at an f prime graph? It's going to be the x-intercepts if you're looking at a graph. Or a table, it would just be when it equals 0, when f prime equals 0. So what I'm doing is, these are statements about f of x. This is how you find it from f prime of x. Maybe I should label that. So the f of x max and mins are going to be at the x-intercepts of the f prime graph. So then the f of x is going to be increasing when f prime is positive. So what is that on a graph? When is your function positive? When it's above the x-axis. Or if you were looking at a table, you would just see when is it positive. But don't forget, on a table you don't know what's happening in between. When f of x is going to be decreasing when f prime is negative. So how do you know if you're looking at the f prime graph, you're going to look at when it's below the x-axis. So when f prime is below the x-axis, f of x is decreasing. When does f of x have point of inflections? We already said on the front when f double prime is 0 or undefined. But how do you get that from the f prime graph? That's because, remember, f double prime is the slope of f prime. So when, oh wait, I'm talking about concavity. I was just thinking, I was jumping ahead. So when is the slope 0? Because this is the slope of f prime. at relative max and mins. So you're going to be looking for, on f prime, you're going to be looking at the relative max and mins. So f of x is going to have point of inflections where f prime has relative max and mins. And then when is f of x going to be concave up? Well, when f double prime is positive, which is this slope. So when does f prime have a positive slope? When f prime, I guess I haven't been writing f prime, so I'm just going to write when it's increasing. So f of x is going to be concave up when either f double prime is positive above the x-axis, which they're not going to normally give you f double prime. They're going to give you f prime. So f of x is concave up when f prime is increasing, which means f of x is concave down when f double prime is negative, which means f prime of x would be decreasing. So if they give you an f prime graph and you're making a statement about f, go back to here and see if this helps. This says if f prime is positive, f of x is concave up and has a relative minimum. What if, I feel like that's not complete. Hold on. This, I feel like I didn't read this closely before I started my video, and now I'm noticing that I could have done something else with this. What I want to change this to is if I'm going to say if f prime of x equals 0 and f double prime of x is positive. So I'm going to change that to double prime. So what do we know if this was our situation? We know f prime of x equals 0. That tells us that f of x has a relative max or min at that spot. And then if f double prime is positive, that tells us that it's concave up. So if we draw concave up, and if this is the spot that we have our, then that, I can't talk, that relative extrema would have to be a minimum. If we already determined that f prime equals x, f prime of x equals 0, so there has to be a max or min there, well then check the concavity if you're trying to decide is it a max or min. Well, if it's concave up at that point, it would have to be a minimum. If f prime of x equals 0 at a point, but your function is concave down, so make this f double prime. Well, if you draw concave down, then that relative extrema would have to be a maximum. So concavity can also help you determine is your critical point of max or min. I hope that made sense because that was not well thought out ahead of time. Let me know. I need to redo that. Okay, so the last thing is talking about if you're trying to find values for f of x, but they give you f prime. So be careful, always check your signs. If you're finding a value, make sure you're using the same function that you're trying to actually evaluate. So it says take the integral of f prime, right? That's how you go backwards to f. But then you have to also make sure that you use the initial condition. They should give you some initial condition if they're asking you to do this. And then also remember to solve for your integral. It depends. You could use, well, let me go ahead and fill this out. It means area, right? So there, we'll get more into this when we review chapter 4, but to solve a definite integral, you can write this down after I say it if you want. You could use the calculator if it's calculator section. You could use fundamental theorem of calculus. You could use area using geometry underneath your graph if they give you a graph, or you could use properties of integrals if they give you certain values and you can piece it together. That fourth one's kind of probably not going to be that one. It's probably going to be calculator, FTC, or area under the graph. So this is the format. So what this comes from is your fundamental theorem of calculus. So we know fundamental theorem of calculus is, oops, not that, solve an integral from a to b of a derivative f prime of x. How would you do this? You take the antiderivative. So what's the antiderivative of f prime? F of x. And you do f of b minus f of a. So if I want to manipulate this to solve for just f of b, and f of a is like your initial condition they give you, you can move it over to the other side and add it. So then you'd be left with f of b alone equals, you added your f of a over here to the integral from a to b of f prime of x. So that is the same thing. I didn't type that. I don't remember where that came from, but it's C and K. So just don't forget, you got to always add that initial condition and let f of b be the y value you're looking for. And so also this could tie into if you wanted to write f of x as a function, right? Let's say they gave you the f prime function or the f prime graph, but you need to have an f of x function, maybe to find the absolute min or max to plug them back in. You could just say, okay, well b is x, so f of x equals that initial condition plus the integral from a to, remember I just said b is x, of f, oh, what should I be writing? My dx. And now here, sometimes they change this to t so they don't match, but they won't ever take off. If you kept these all x's or you changed it to t, it doesn't matter. And you would just plug in, if you're trying to evaluate different values for f of x from the f prime graph, you would just plug it in as that b boundary. You just keep adding to that initial condition. If that didn't make sense, we're going to spend a lot more time on that with different FRQs, so don't stress on this right now. If this is really what chapter 3 is over. And then the justifications. So make sure when you're doing your free response that you write sentences, you do not just leave it as a sign chart. So you're going to say blank is a relative maximum because, and do not say it or graph, because f prime changes signs from blank to blank, or it's a minimum, or not blank to blank, maximum needs to change from positive to negative, minimum because f prime changes from negative to positive. Point of inflection because f double prime changes signs, or just be very clear, say because what are you talking about, f prime, f double prime, and what does it do? And again, reiterating the fact that absolute extrema can occur at endpoints or critical points, and you need to plug them back into the original, which is why I was trying to talk about this. But again, I kind of regret bringing this in because I don't want y'all to stress on that. I want you to focus on this stuff up here. So I hope that helped. This is an important chapter, and I do think different perspectives is helpful. So if you feel like this stuff is still getting jumbled in your brain, I'm going to attach Khan Academy, so if you have the time, I would suggest watching through some of those or getting with a friend and having them explain it. So if you're working and you need more help before your assignment is due on Monday, let me know. We can do a Zoom call for questions if you need to. So y'all have a great weekend, and let me know if you need anything.